Find the distance from A to B. So we have a graph, we have 2 points A and B, and this length is on a diagonal, so I can't just go ahead and count it. That will not be accurate. So one way to find the distance from A to B is we can use Pythagorean theorem. Pythagorean theorem only works for a right triangle. So let me create a right triangle such that in that right triangle this is one of the sides. So I'm going to do that now. So I go straight down and then across, and that is my 90-degree angle. So I created a right triangle where AB is the hypotenuse, and then we have the legs here that form a 90-degree angle. So now I want to find the distance from A to B. So Pythagorean theorem, if you have to recall that if you have a right triangle and if you make a square off of the legs of that triangle, the relationship should be that if this is length A and I made a square out of it, then I know that this also would be length A, and the area of that square would be A squared. And if I have a length of this side, let it be represented by B, and I made a square, then that means this would be B and this would also be B, and the area for that would be B squared. So the area of this squared and the area of this squared. And if I let this length be represented by C and I made a square off of it, this length is also C, and the area would be C squared. And Pythagorean theorem says that if you square, or if you add the squares of each leg, so A squared plus B squared, which are the areas of the legs, those two should equal the area of the hypotenuse. So this hypotenuse squared. So that's the relationship that Pythagorean theorem lets us know. And since I have a right triangle, I can use that relationship. So I'm going to redraw this on the side, and I look at the distance from here to here. So from my base of my triangle, I count it. This is 1, 2, 3. So that's a length 3. And this length here would be 1, 2, 3, 4. So that's length 4. And if I apply Pythagorean theorem, I'm going to make my squares, and then I make my square off the hypotenuse. I'm going to find the area of this one. This would be a 3 by 3 square, so the area is 9. This is a 4 by 4 square, so the area is 16. I don't know the length of this, but I know that if I add these two areas, the areas of the legs, or the squares of the legs, that adds up to 25. So that's the area for this square. If I know the area of a square, but I simply want the length of the side for that square, what you can do is you take that number, or area, you find its square root. So the square root of 25 is 5. And I can check that because if I have a square with length 5 by 5, 5 times 5 is 25, so my area, it works out. So I know this has length 5, and if I look at my picture, the hypotenuse here, which is 5, well, that was just the distance from A to B, which is 5. So the distance from A to B, I can say, is AB. That's how you write the distance from A to B. That is equal to 5.